we always have D vector perpendicular to the K vector. Suppose I consider the Kx, Kz plane, and here this direction is Ky direction. This is known y unit vector. Then suppose we have a wave propagating along an arbitrary direction k in the Kx, Kz plane, and have the D vector at the D vector along the y direction. We choose D to be along the y direction. And since along this direction, when the D vector is along the principal axis, one of the principal axis, the relation between D and E is very, very simple, because this is equal to epsilon y times Ey, and D is parallel to E. Okay. So in this case, if I replace the original anisotropic medium by an isotropic medium with epsilon equal to epsilon y, the wave will not feel any difference. OK， 那如果我只是在这个特殊情况下，我把原来是 anisotropic 的介质的这个介质换成偷天换成一个 isotropic 的介质，但它的 epsilon 就是 epsilon y 的话，在这种情况下，这个波感受不到任何差异。可是，在 isotropic 的介质的时候，你会得到一个什么样的 k 跟 omega 的关系？就是圆形。I replace the original anisotropic medium by isotropic medium with epsilon equal to epsilon y. The wave will not feel any difference. And in an isotropic medium, the relation between k and omega is just the circle. If a fixed omega is given, then so this explains why we get a circle of radius equal to ny omega over c. Okay, because the n corresponding to epsilon y is ny. However, let's consider the second possibility. The second possibility, I may denote it as D prime. D prime has x component and z component. K dot D is equal to 0, and K dot B prime is also equal to 0. Then corresponding to this D, since D is related to x by this relation. And along different direction of D, the two components of E vector related to different coefficient, epsilon x and epsilon y. And since epsilon x is not equal to epsilon y, the different propagation direction will give us different effective refractive index. Okay? And in this very special direction, say k is along the x direction. When k is along the x direction, this means that D prime has only dz component. When k is along x, D in this KXKT plane has only z component. And this z component gives us nz. So this direction gives us the corresponding refracting index equal to nz because the D vector is along the z direction. Okay, 好，就是在这个非常特殊的方向，当你的 k 只有 x 分量的时候，然后你的 D 又是躺在 KXKT 平面上的时候，你的 D 又跟 k 垂直的时候，可见你的 D 只能够朝地方向。那当 D 只朝地方向的时候 ，E 也是朝地方向，所以折射率变成 nz。OK， 好。那另外一个情况是 ，so when the k vector corresponding to this situation is along the z direction, then the D prime vector is along the x direction, and this brings out the nx refracting index. Okay, and then in between, you must solve all the refracting index from the so-called normal surface equation. Okay. 至少在这几个特殊方向上，你可以很容易解读出这些 n 是什么意思。So along x direction we have you have refracting index equal to nz or ny. Nz means that the D vector is in the KXKT plane, and ny means the D vector is along the y direction. Okay. 好，这个解释了4至8的这几个图。So this facts explain the shapes, curves in the 3 possible coordinate planes. 好，那我们在下一个要讲的就是，如果是考虑这个 uniaxial crystal 的时候会是怎么样 ？So now we consider the uniaxial crystal. Now we consider uniaxial crystal. For uniaxial crystal, we mean that nx is equal to ny or ny is equal to nz or nx is equal to nz. Okay. Uniaxial crystal. 2 of them are equal. Okay. So, since it is convenient to assume that ny is smaller than nz, so we just consider this situation. if we consider this situation, what result we will get? Now we are not trying to restrict ourselves to the plan. We want to